Okay. Hello, guys. Are you guys online? Hello. Wow. Hold on. Hello. Testing the microphone. It's very bad. Okay, guys. So we are starting now. Sorry for the little interruption. I needed to fix. The network is seriously bad here. We are starting very soon. All right. Are you guys online? Let's keep on sharing the link. Okay, so we are starting now. I think we are just few persons online. There's an we having network issue. Sorry for the inconveniences. Okay, so we're going to looking at complex number in mathematics. All right. Please, I hope every one of you can see the board. Sorry, I have to change my phone immediately. The other Samsung phone is overheating, so I have to just change my phone. I hope this other phone, you guys can see the board clearly, right? If you can see the board clearly, just indicate in the comment section so we can proceed. Please indicate, all right? Please indicate in the comment section if you can see the board clearly. Okay, in mathematics, when you hear the word complex number does not really mean that things, maybe a number that is complex per se. It comprises of two major parts. When you hear the word complex number is a number that has two major parts. A number that has two major parts. A number that has two major parts, okay, which are the real parts, the real, the real parts, and number two, the imaginary parts, the imaginary parts. Any number that has these two major parts is called what? A complex what? Number. All right. The general expression for all complex number is given as z equals a plus bi or z equals x plus yi. All right. Where the value of a represents the real parts, while the value of b represents the imaginary part. Imaginary part. All right. It means the imaginary part. All right. S here also represents the real part. Y represents what? Imaginary part. All right. So what we are saying is that complex number are those numbers that have two major parts, which are the real part and what? Imaginary what part. Are you there? For example, the general expression we have already seen is this, right? If I have if I have a number, let's say z equals to 2 plus 3i, you can see that this number here comprises of two parts, right? We have 2 and we have what 3i. What actually makes these three, this part to be imaginary? Because there's a complex value called I attached to 3. So 2 is referred to as the real part of Z. The real part of Z is what is 2. Why the imaginary part of Z is what is 3. The real part of Z is what is 2. Imaginary part of Z is what is 3. Why do we say 3 is imaginary? Because it has a complex value I attached to it. So any number that has two major parts, which are the real part and the imaginary part, are referred to as what? Complex what? Number. Now let's look at another example. Okay. All right. If we have number 2, let's say if z equals to 3 plus 4i, that implies that if I'm to bring out the real part of this complex number, the real part of this complex number z is actually what? 3. While the imaginary part of the complex number is given as what? As 4, right? Okay. I've already explained why we said this value here is imaginary, because it has a complex value called what? I. Along this class, I will explain what this I represents in complex number and how do we come about this I. We also look at the derivations and evaluation of what? Of I. All right. Okay, now let's proceed. Let's look at some basic operations. Some basic operations in complex number. Some basic operations in complex number. Please, if you are following, if you're online, I want you to do me a favor. Make sure you comment in the, you send a message in the comment section. I want you also to be active and interactive at the same time. All right. Okay, please. I want every one of you to ensure that you follow up throughout this class. Please, very important. If you have any question you don't understand, you let me know. The essence here is for us to learn together. All right. Now, at the end of the day, I'll be solving Imo State University past questions in line with UNN University past questions, all right? Because this link was also shared among other university students and all that. This is a global class, a global classroom for all Emi-Brain students, all right? So please, if you have any question you want to ask, I would like you guys to ask, all right? Okay, for the sake of those who just join us, we define complex number. We're looking at complex number as a number that has two major parts, okay, which are the real parts and what imaginary part. I will say the general expression of complex number z is given as a plus bi or z equals to x plus yi, right? These are the general expression of complex number, where the value of x is equals to a, equals to the real part, while the value of b is equals to y, okay, or can say y is equals to b equals to what? Imaginary part. So the combination of the real parts and the imaginary parts gives us what we call a complex number. For example, if we have z equals to 2 plus 5i, here we are saying that the real parts of z is 2, imaginary parts of z is 5, not 5i, not 5i. Why do we say it's 5? Because this 5 here has a complex value called I. And I said along this class, I will be explaining how we come about the value of I. Now let's look at some basic operations in complex number. Some basic operations in complex number. Some basic. The first basic operation I want us to look at is what we call addition and subtraction. Addition and subtraction of complex number. Addition and subtraction. Addition and subtraction of complex number. All right? Addition and subtraction. Now let's take notes. Just write briefly. Addition and subtraction of complex number, we always result to the formation of a new complex number. When you add up two or more complex numbers together, the result will always be a formation of a new complex number. For example, let's say we are given that z1 equals to a plus bi and z2 equals to c plus di. And we are asked to find z1 plus z2. What we are doing here is that we are adding, right? Let's say we have to find the number 2. We also have to find z1 minus z2. Now, how do we find z1 plus z2? While adding complex numbers, what we do is to add up the real with the real, then imaginary with what? With imaginary, right? We add up the real with what? The real, imaginary with what? Imaginary. Are you there? So what we do here is to add up z1 plus what? z2 will give us our z1 plus z2. I will add up the real. The real for z1 is what? Is a, while the real for z2 is what? C. That will give us what here? A plus c plus. Then I'll add up the imaginary parts, bi plus what? Di. What do we do here? Since I'm adding bi with di, I'll just add up b plus d. Then bring out the common factor, which is I. And that will give us what here? B plus what? D. All multiply with what? With I. This is how to add complex number. For example, okay, let's find this. Number 2 first. If I'm to find Z1 minus Z2, the same thing we apply there. In subtracting complex number, we subtract the real, then also subtract what? The imaginary. That will give us what here? A minus C plus, for that of the imaginary part, that will give us B minus D, or multiply with what? With I. What happened here is that we subtracted this A minus C, then we have our plus sign, then we have B minus D, all times what? Times I. For example, let's see an example. Let's see an example. Example 1. If we are given Z1 equals 2 plus 5I and Z2 equals to 4 plus 3I, and we also find Z2 plus Z1. Number 2, find Z2 minus Z1. All right, let's solve this. To find Z2 plus Z1, what we do is to add up, right? 2 plus 4 will give us 8. Is that not? Okay. Then for Z1, 5I plus 3I will give us, 2 plus 4 will give us 6 rather, plus 5I plus 3I will give us what here? 8I. Now we add up the real. 2 plus 4 is 6. Then 5I plus 3I is what? Is 8I. Then for the imaginary part, what do we do to subtract? Here we are subtracting Z2 minus Z1. Z2 minus Z1, that means 4 minus 2 will give me what here? 2, right? Then 3I minus 5I. When you're subtracting a smaller number from a bigger number, the result must be negative. I hope you are aware. So that means for this, 3I minus 5I will give us minus what? 2I. Let's repeat again. If Z1 is 2 plus 5I and Z2 is 4 plus 3I, we also find Z2 plus Z1, meaning 4 plus 2. That will give us what? 6. Then 3I plus 5I will give us what? 8I. Then for Z2 minus Z1, we are subtracting this, right? That will give us 4 minus 2. That will give us 2. Then 3I minus 5I, that will give us minus 2I. I hope you are following. Please, like I said, if you don't understand anything in this class, just make sure you indicate in the comment section. I'm open to entertain questions, all right? And let's keep on sharing the group link to other people in your platform. Please keep on sharing it. There are people that need this platform, that need this class right now. There are those that need this class right now. Let's share the link to them for them to join. All right? Okay, I want us to look at something very important before we go into other basic operations. Although we have seen addition, right, and subtraction, let's look at derivation of I. If we are saying that complex number is given as x plus yi, right? X plus yi. What does this I represent? How do we come about this I? Let's look at the derivation. Derivation of what? Of I. Are you there? Okay. For instance, if we are given in mathematics that x squared plus 1 equals to what? 0, and we're asked to find x, we have to find x. This is a very simple question, right? For most of us, all right? But this is a concept where the value of I is being introduced, okay? So from here, if x squared plus 1 equals 0, and we have to find the value of x, what we have to do here is that we have to make our x squared to stand alone as the subject of the formula, right? So that means here becomes what here? Our x squared equals to, when you move this 1 to this other side, here will be 0 minus 1, right? Or we subtract 1 from both sides. Is that not? And that will give us what here? X squared equals to minus 1. Okay. In mathematics, if we have a function like this and we have to find the value of x, and the value of x is being squared, the only way to solve for this is to look for a means to eliminate this square, right? I cannot find x if I have square here. So what we do is to square root both sides. We have to square root both sides, right? We have to square root what? What? Both sides. By the time we square root both sides, square root of x squared is equal to square root of minus 1. Yes, square is allowed to cancel out with what? Square root, or is allowed to cancel square root. If this should happen, that means my x is equal to what? Square root of what? Minus 1. By the time you punch your calculator to find the root of minus 1 or the root of any negative number, you're going to have what we call mathematical error, meaning it's not possible to find the root of a negative number. Okay? It's always undefined. It's always what? Undefined. So when you punch it, you can try it out on your own. Those watching, just try and press in your calculator the root of minus 1. You will find out that the answer is what? It's not possible. Sometimes they will give you math error, right? Now, to define this, I can't just say it's not possible. I have to define this. This is where complex root comes in. This value here represents a complex root. A complex root are those roots that their discriminant is less than what? 0. I will come back to that. These are part of the things we'll look at. We have 3 kinds of roots. We have what we call a complex root. We have what we call real roots and equal roots. A root can be complex. A root can be real. And a root can be what? Equal. When a root is complex, means discriminant is less than 0. When a root is real, means discriminant is greater than 0. When a root is equal, means discriminant is equal to 0. I'll come back to this. Just take note. So for this, discriminant is less than 0. Okay, for this. As time goes on, I will explain why discriminant is less than 0. But let's just evaluate this. Since this is not possible, but I want to define the answer to this. I can't just assume that this is not possible in mathematics. So what we do is to introduce, I will say let x equals to what? I. Let x equals to I. Are you there? In engineering, we use J. Some will say let x equals to what? J. Are you there? But in pure mathematics, we are using just I to represent what? X. So if x equals to I, that implies that the value of x, rather, the value of x, if x is I can replace this with I, right? That implies that I is equal to square root of what? Minus 1. This is the first thing I expect. I want every one of you, rather, to note that I in complex number represents what? Root of a negative number. Okay, if s equals to I, and I'm saying that s squared is minus 1, right? That means I can replace my x as what? I. If x equals to I, and we are saying s squared is minus 1, does that also imply that I squared is equals to minus 1? Also take note of this. So you must have to note that the value of I is root of minus 1. Also, as time progresses, I will also explain that I is also 90-degree turn in your Cartesian diagram. 90-degree turn. I also represents a 90-degree turn. As time goes on, when we proceed, then in polar form of complex number, we'll look at how can we evaluate I using the Cartesian diagram. And I will prove that the value of I in complex number represents 90-degree turn, all right, in the polar diagram. Are you there? So just take note of this, that first of all, I represents what? Root of what? Minus 1. And I squared represents what? Minus 1. Please, if the board is not clear, please try and zoom it. You can zoom it and use a landscape, okay? I'm not using my Samsung phone. So please, in the next class, I will make sure that I work on the camera, all right? So please, is the board clear? Is the board clear? Can we proceed? Please, if you're not seeing the board, use horizontal landscape, then zoom it up, okay? Zoom it up, zoom your video and all that, so we can proceed. Please, I will need you to comment. Are you guys seeing the board? Please, I need your comment. Are you guys seeing the board? Let's proceed. Take it back. Okay, so we can proceed, right? Some of you say you are seeing the board. Okay, I'm seeing your comment already. All right, thank you. Please, let's keep on commenting. Can we proceed? Can we proceed? Is the board clear? Is the board clear? Please, let's view. Let's view. I will work on this in the next class so that we can have a proper view. All right? Are we there? All right, so let's look at. So let's proceed further. Okay, so we have seen how to derive I. Let's look at how to evaluate I, right? How to evaluate I. How to evaluate I. How do we evaluate I? Okay, evaluation of I. Evaluation of I. Of I. Very important. Now, whenever you are evaluating I, just note that the value of I in evaluation will not go beyond um either I itself, comma, minus I, minus 1, or 1. These are 4 possible answers you will always have anytime you are evaluating what? I. But note fundamentally that we have seen that the value of I is equals to what? Root of minus 1. Then the value of I squared is equals to minus 1. Okay. Now let's evaluate I. Don't forget that there are 4 possible answers you can only always have anytime you are evaluating I, which are either I, minus 1, or what? Or 1, right? Okay. So let's go. Let's move on. So for this, we have evaluate the following. Evaluate the following. Evaluate the following. The first one, we have I squared. Number 2, I raised power 3. Number 3, I raised power 4. Number 4, I raised power 7. Number 5, I raised power 10. Number 6, I raised power 12. Number 7, I raised power 13. I guess I'll stop here so we can proceed. Now for I square, we all know that the value of I square represents what? Minus 1, right? We have defined I square as what? Root of minus 1. That means my I squared minus 1. Then to evaluate I raised power 3, what I have to do here is that I have to reduce this I raised power 3 to the simplest, but starting with what first? I squared. Now don't forget that according to the law of indices, the I cube can be expressed as what? I squared times what? Times I, right? In indices, if I have A raised power 2 times A itself, the answer represents what? A raised power 2 plus 1, which is A raised power 3, right? The rule says pick a common base and add up the power. The power of A is 2, the power of A is what? Is 1. So when you add up 2 plus 1, that will give us what? 3. So for this, I can express I raised power 3 as I squared times I. And that will give us what here? The value of I squared is minus 1. Don't forget. Minus 1 times what? I. Alright? So if we should multiply this, minus 1 times I will give us minus what? I. Alright? Okay. So that means the answer to this is simply minus I. Then for that of I raised power 4, I raised power 4 can be expressed as I squared times what? Times what? I squared, right? Because 2 plus 2 is what? Is 4, right? So for here, we can say that this will give us what? I squared or raised power what? 2. I can either express this or as this. 2 times 2 is still 4. So from here, we can have our final answer becomes what here? Minus 1 or raised power 2 equals to what? 1. Minus 1 raised power 2 minus 1 or raised power 2 is same as minus 1 times minus 1, right? What's minus times minus is plus. What's 1 times 1 is 1, right? So for this, let's express this. Let's evaluate this. Here we have I raised power 7. This can be expressed as I squared. I'll bring up my I squared. That's the first rule. When you bring up I squared, you will now look for a factor of number that I can multiply 2 with. That will give me a number either 7 or close to 7. So here I can say I squared or raised power what? 3, right? Because 2 times 3 will give us what? 6. So the value of I is what? Is the power of I is what? Is 6. So I need an extra I to make it what? 7. So here will give us times what? Yeah? Times I. So that 2 times 3 will give us 6. Then plus 1, which is what? 7. So what we have here? Here becomes what? Let's evaluate this together. Here becomes minus 1 or raised power 3 times I equals minus 1 raised power 3 will give us minus 1 times I. The answer becomes equals to minus what? I. I repeat again. I squared raised power 3 The value of I squared is what? Minus 1. Okay. All raised power 3. Then times what? Times I, right? Okay. So here we have minus 1 times I equals to what? Minus what? I. Sorry for the disturbance. Okay. I know I'm getting a noise outside. So please just bear with me. So for this, how do we evaluate I raised power 10? I raised power 10, that will give us what? I squared, right? What will I multiply by 2 that will give me 10? That should be raised power 5, right? And this will give us what? Minus 1 or raised power 5 equals to minus 1. What do you notice here? Anytime we are evaluating minus 1, let me show us something very important. Please take note. Take note that minus 1 raised power even number is equals to 1. But minus 1 raised power odd number is equals to minus 1. Let me explain this. If you look at this, minus 1 raised power 3. 3 is odd number, right? The result is what? Minus 1. Then times I, that will give us what? Minus I. Also, minus 1 raised power 5. 5 is odd number, right? Is that not? So minus 1 raised power 5 will give us what here? Minus 1. Let's look at this. For I raised power 12, I'll bring out the simplest value of I, which is what? I squared, right? What will I multiply by 2? That will give me 12. Is 6, because 2 times 6 is what? Is 12. And this will give us what? Minus 1 raised power 6. Now the question is, will the value of minus I raised power 6 be positive 1 or negative 1? I said, whenever we have minus 1 raised power even number, the result is what? Is 1. Minus 1 raised power odd number, what's the result? Minus 1. So for here, minus 1 raised power 6, 6 is even, right? So my answer will be what? 1. Positive what? 1. Okay. The next question here is I raised power 13. To evaluate this can be splitted into I squared or raised power 6 times I. There is no direct number I can multiply these two without giving me 13. But I have a number close to what? Close towards 13, which is what? 12, Abi? So here will be I raised power 2 times 6. This value of I here is what? Is 12, right? Then based on the law of indices, the power of I here is what? Is 1. So 12 plus 1 will give us what? 13. So for this, we have minus 1 raised power 6 times I, all right? This will give us minus 1 raised power 6. 6 is even, right? So the result will be what? Will be 1. The 1 times I will give us what here? I. Okay. This is evaluation of I. There are many of them. We can evaluate I raised power 20, I raised power 35, I raised power 100, I raised power 50, and the rest. Why I'm showing us how to evaluate I is that there are some aspects of complex number that we have to use binomial expansion for. For example, let's say we are giving this in complex number. If we are giving this in complex number, for instance, if I have 3 plus 4i, all raised power 8, or all raised power, let's say 4, okay? Then after expanding this, I will need to adopt the principle of evaluation of I to simplify further. Anytime you are evaluating complex number, the result must always result to a new complex number. Okay, take note. That means at the end of this expansion, I will end up having what? A real part and what? Imaginary parts. All right? Okay. All right, so I won't go into this now. As we proceed, we'll solve many of these exam questions. All right? Now, I want us to look at the next application. When we started this class, we look at some applications, Abi. Some applications in complex number. Some applications in complex number. Please, I hope you are seeing the board. I hope you are seeing the board. Please, I need your comments. I need your comments. I need your comments. Hope you are seeing the board. Please comment if you are following up the class. Please comment, comment, comment. Okay, please comment. Please, I want to see your comment if you are following, so that let's know if we are progressing or not. Are you guys following? Okay, I want us to have a review again. After seeing how to evaluate I and derive I, we talked about some applications, and I mentioned just one, which is under addition, right? Under addition and what? And subtraction. Is that not? Under addition and what? Subtraction. And I mentioned that the addition and subtraction of two or more complex numbers will always result to the formation of a new complex number, right? For instance, I won't go into details again. I've already explained this part before. For instance, if we are given that Z1 equals to 2 plus, okay, let's say 3i, then Z2 equals to 4 plus 6i. And we also find number 1, Z2 plus Z1. Number 2, find Z2 minus Z1. This is very simple, okay? Now, to solve, addition of complex number means I will add up the real part with the real part, then add up the imaginary with what? Imaginary, right? The real part here is 4 for Z2. The real part here is what is 2. So 4 plus 2 will give us what here? 6. 6 plus 6i plus 3i, that will give us 9i. That's how simple this can be, right? Okay, under subtraction, Z2 minus Z1, I will subtract the real, then subtract what imaginary. 4 minus 2 is simply 2, right? Okay, plus 6i minus 3i will give us what here? 3i. This is how simple this can be. Then you might be asked to find the real part of Z1. The real part of Z1 is 2. The real part of Z2 is 4. The imaginary part of Z1, imaginary part of Z1 is 3. Don't forget, imaginary, we don't indicate I. It's just on this 3. What makes 3 imaginary? Because it has a complex value I attached to it. So likewise, the imaginary part of Z2 will be what here? Will be 6. Thank you. Okay, now, what if we have to find the imaginary part of Z1, rather, of Z2 plus Z1? Meaning that after adding Z2 plus Z1, what is the imaginary part? The result is what? Is 6. Sorry, the result is 9. Thank you. The result is 9. The imaginary part is 9. But the real part of Z2 plus Z1 will be 6. The real part is 6, right? Okay. That is how simple this can be. Now let's look at other operation. Other operation. The next operation we'll look at is multiplication. Multiplication. Okay, so the next operation, multiplication of two or more complex numbers. Multiplication of two or more complex numbers. Okay, if we are to multiply two or more complex number, okay, the results will always give us a new complex number, like I always say, right? For a example, if I have z1 to be equals, let me pick from your past question, equals to 2 plus 3i, then z2 is equals to 1 plus 4i, 1 plus 4i. This is IMSU past question, Imo State University past question, all right? So if we are to find, and we have to find, okay, we have to find number 1, z1 times z2. Number 2, we have to find 2z1. Number 3, we have to find 3z2. Okay. Now to solve the first one, this is very simple. Number 1 says find z1 times z2. Now to find z1 times z2, our z1 is 2 plus 3i times z2 is 1 plus 4i. Okay, what we have to do here is a simple multiplication process. Multiply this 2 with 1, multiply this 2 with 4i, multiply this 3i with 1, then 3i with 4i. Let's proceed. So z1 rather times what? z2 will give us 2 times 1 is 2, 2 times 4i is 8i, right? 3i times 1 is 3i, all right? Then 3i times 4i will give us what? 12i squared. That is how simple it is. Let's go again. 2 times 1 is 2. The same 2 times 4i is 8i. Then 3i times 1 is 3i. 3i times 4i is 12i squared. How do we get 12i squared? 3 times 4 is 12. Then I times I is what is I squared, right? Okay, in this case here, my z1 times z2 becomes 2 plus. These two, they are like terms, so they can be added together. 8i plus 3i will give us what? 11i, right? Okay, plus 12 times. Don't forget that in complex number, we have already expressed that I squared is equal to minus 1. Don't forget this. So that means I will replace this I squared with what? With minus 1. When that happens, that will give us what here? 2 plus 11i minus what? Minus 12. Then I can further evaluate this, right? 2 minus 12, that will give us minus what? 10 plus 11 what? I. Final answer to this. Okay. I'll repeat again. 2 times 1 is 2. 2 times 4i is 8i. 3i times 1 is 3i. 3i times 4i is 12i squared. But 3 times 4 is 12, right? Okay. Then I times I is what? Is I squared. All right. So for here, 8i and 3i are like terms. 8i plus 3i will give us 11i. We have our 2 here already. Then plus 12 times minus 1. I squared is minus 1. Don't forget. Then if I squared is minus 1, meaning minus 1 times 12 will give us minus 12, right? Then 2 and minus 12 are real parts. They can be added together. If we should add them, 2 minus 12 give us minus 10, right? Okay. Then plus 11i. So that means that the real part, this is the final answer. But if you're not asked to find, let's say we asked to find the real part of z1 times z2, what will be the result? The real part is minus 10. Then the imaginary part of this will be what? 11, not 11i. 11, not 11i. Now the next is to find 2z1, okay? 2z1. Let's solve for 2z1. Okay, number 2. For 2z1, that will give us 2 times. Our z1 is 2 plus 3i, right? And this will give us 2 times 2 is 4. Okay, then 2 times 3i, that will give us 6 what I. Final answer. Very simple. 2z1 means 2 times z1. So that means I'm multiplying these 2 with z1. And z1 is what? 2 plus 3i. So 2 times 2 is 4. 2 times 3i is 6i. Number 3 is 3z2, meaning 3 times z2. Our z2 is 1 plus 4i. Let's proceed. That will give us 3 times 1 is 3. 3 times 4i will give us what? 12 4i. Okay. What if we are asked to find, let's say 2z1 plus 3z2? What if we are asked to find this? How do we solve for this? This is very simple. I'll bring out my 2z1, which is 4 plus 6i, right? Plus 3z2, which is 3 plus 12i. So in addition, don't forget while adding, we add the real to the real, imaginary to imaginary. So 4 plus 3 will give us 7 plus 6i plus 12i. That will give us about 18i. Okay. Okay, let's repeat again and see what we have here. 2z1 is 2 times z1. 2 times 2 is 4. 2 times 3i is 6i. Then 3z2 give us 3 times z2, which is 1 plus 4i. 1 times 3 times 1 is 3. 3 times 4i is 12i. Then if I'm to add up these two together, this and this, right? It means that we have our 2z1 as this, 3z2 as this. So 4 plus 3 is 7. 6i plus 12i is 18i. Okay, this is all about multiplication. Then the next I want us to look at would be let's look at the next one, the next application, which is modulus of a complex number. Modulus of a complex number. Modulus of complex number. Modulus of complex number. Now, the word modulus is same as the word length. It means the length. It means the length of complex number. Length of complex number. It also means the word size, also known as the word magnitude of complex number. Magnitude of complex number. It also means the word absolute value. Absolute value of complex number. Either it means the length, it means the size, or the magnitude, or it means absolute what? Value of complex number. All right. So it has variety of meaning. Okay. Now I want us to look at it here. I don't want to just derive the formula or give the derivation. Let me just show you a little bit about this modulus of a complex number. Are you there? Look at this. If we are saying that z is equals to x plus yi, meaning that in the Cartesian diagram, right, the y-axis represents the imaginary part, while the x-axis represents what? The real part, right? If we are saying that generally complex number is z equals to x plus yi, where x represents what? The real abi, y represents what? The imaginary, right? It means I can represent the value of z in an Argand diagram or in a Cartesian diagram, which is what I just did here. Here we have both, here is y-axis, here's what? X-axis. This part is called negative y, this is called what? Negative x, right? This is positive y, this is positive x. So this is a positive real axis. This is positive what? Imaginary axis. This is negative real axis. This is what? Negative imaginary. So if the value of z equals to x plus yi, it means I can represent this z in this Cartesian diagram. I can represent this here. Why do we have to put this diagram here? Because x is positive, y is not positive. So on this side, I have positive x-axis. I have a positive what? Y-axis. So I'm representing my complex number z generally in the first quadrant, right? So here we have here to be y, we have here to be x. Okay, this line here that started from the origin is called the length of the complex number, which is also called the what? The modulus of the complex number. The modulus of complex number, also called the length. We use the value of r to represent the length. Let's call it point O, point A, and point what? Point B. Don't forget how we started, that z equals to what? X plus yi. Both x and y are positive, so we represent this complex number in the first quadrant of the Cartesian diagram, right? Okay, and don't forget we say that the y-axis represents what? The imaginary part, right? X represents the real part. So this is positive imaginary, negative imaginary, minus y. Okay, this is what? Minus x. Negative real, this is positive real. But because I'm considering the general expression, which is z equals x plus yi, positive x and positive y. So that means the Cartesian diagram will fall in this Cartesian plane here, right? That shows that y is positive, x is what? Positive. We have an angle called what here? Theta. Okay. As time goes on, I will explain this. Okay, I'm not introducing polar form yet. There's a form called polar form of a complex number where we have to involve the angle theta. Okay, but for we to find the modulus, we're looking for the modulus of a complex number. How do we derive the expression for this modulus of a complex number, or the length of a complex number? Whenever we have a right angle triangle, the only rule that can be used to find any side of this triangle is called the Pythagoras theorem, right? Okay, I'm going to introduce using Pythagoras theorem. Pythagoras what? Theorem. Okay, the theorem says that the square of the hypotenuse equals the square of the adjacent, or the square of what? The opposite. Okay, so the longest side that represents the length represents what? The hypotenuse, right? This side that faces this angle is called what? The opposite. Then the other side is called what? The adjacent. So what this theorem is saying is this, that square of AB squared, right? Rather OB, right? Okay, we are using here to be O. Here is A, here is B. See what? Square, right? The value of OA represents what? Either this or this. AB is Z modulus, which is equals to what? R, right? Okay. All what? All squared. Or let's just use the value of R. R squared, right? Equals to what? OA is what here? Is S squared plus AB is what? Is Y, which is Y squared. Is that not? Okay. So from here, I can actually square root both sides to remove this square from this R. By the time we square root both sides, we square root both what? Both sides. This will give us what? Square root of R squared, right? Equals to square root of S squared plus what? Y squared. So square can cancel square root here. then my value of r becomes equals to what? Square root of what? Of x squared plus what? Plus y squared, right? Okay, but we say that the value of r equals to z modulus. So this also means that z modulus is equals to what? R is equals to square root of what? Of x squared plus what? Y squared. Okay, let's take note of this. So modulus of a complex number, modulus of a complex number is given as z modulus equals to r equals to square root of x squared plus y squared. Please take note of this, okay? Is equals to that. Now let's solve a problem under modulus of a complex number. Let's solve some problems here. Okay, so let's proceed further. All right, so let's look at this. If we are given that z equals to 3 plus 4i, 3 plus 4i, and we're asked to find the modulus of z. Okay, to solve this is very simple. Yeah, the general expression, right? We know z equals to what? S plus what? Yi, right? That implies that the value of my x here is what? Is 3. Y value of y is what? Is 4. X is 3. Y is what? Is 4. Then recall that complex number z modulus equals to r is equals to square root of s squared plus what? Plus y squared, right? So that implies that the value of r, which is my z modulus, is simply equals to what? Our x here is 3 squared, right? Y here is what? Is 4 squared. All equals to what? 3 squared is 9 plus 4 squared is what? 16. By the time we add up this will give us root 25 equals to 5. So the value of our modulus of z is equals to what? 5, right? Is equals to 5. Okay, next question. Let's look at another example. Another example. Then we'll move into another example. Okay, let's look at example 2. Example 2. Example 2. Okay, if we are given this, we are given that z equals to, let's say, 2 plus 5i in this case, or let's use another sign here, 2 minus 5i, and we're asked to find z modulus. This is very simple, right? Z modulus here is equals to square root of s squared plus what? Y squared. Don't forget that for this expression, our x is equals to 2, y is equals to minus 5. Don't forget. Yeah, the value of my x is 2, y is what? Negative 5. Okay? So here will give us z modulus equals to square root of our x, which is what? 2 squared plus minus 5 all what? All squared, right? And this will give us what here? Square root of what? 2 squared is 4 plus minus 5 all squared will give us what? 25. right? Give us 25. Give us 25. Okay. So by the time we add up 25 plus 4, this will give us square root of what? 29. Root of 29. 29 cannot be reduced further, so we can stop here. Okay. In finding your modulus of complex number, avoid putting your answer in decimal. It's either you have a perfect square or you leave your answer in short form. All right, very important. Okay, please let's keep on commenting. If you are following, just comment. If you are following this class, please, if you are following, if you know you are active online, just comment. Let's comment and let's share the link to other people. Okay, like I promised, tomorrow class will be better than today. Even other classes will be better than today. Okay, I'll work on the Samsung phone and see how we can have effective class. All right, please let's comment. Let's comment. If you are online, let's comment. Yeah, someone is asking a question, sir. Please, if we have 10 minus 11i, will the imaginary part be minus 11? Yes, you are correct. It's minus 11. If we have 10 minus 11i, if we have z equals to 10 minus 11i, that means the imaginary part of z will be what? Minus 11, right? Okay, like we saw in this case here, if z equals to 2 minus 5i, that means our imaginary part is what? Is minus 5. Okay, all right. I hope I've cleared you, right? Now let's go into conjugate of a complex number. Conjugate of a complex number. Conjugate of a complex number. So if we're looking at, okay, let's look at conjugate before we go into something else. Conjugate of a complex number. Let's write. Take note that conjugate of a complex number is the reverse sign of the imaginary part of a complex number. Conjugate means the reverse sign of the imaginary parts of a complex number. Okay, if we are given, for example, if we are given that z is equals to x plus yi, that means the conjugate of z, conjugate, the symbol is always this, is equals to x minus yi. The conjugate, okay, of z equals to what? X minus yi. Mean the conjugate of x minus yi is what? X plus yi. The word conjugate means the reverse sign of the imaginary part of a complex number. Just the reverse sign of the imaginary part of a complex number. That's what conjugate represents. Okay. For example, if we have z1 equals to 2 plus 6i, right? That means my z1 conjugate is 2 minus what? 6i. Just change this sign to negative. That is the word conjugate. So if I have this, let's look at another example. Let's say if I have z1 to be 3 minus 4i, what will be conjugate of z1? That will be what? 3 plus what? 4i. Very simple. Just change the sign to the other sign. If the sign here is minus, conjugate of it becomes what? Plus. Okay? All right, so let's proceed further. Okay, please, if you're active, say I'm active. If you're active, please indicate that you are active. Please indicate, 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 indicate. Okay, so let's finish up. Let's finish up. I want us to note very important principle under conjugates. Note this under conjugates. If Z1 equals A plus B, BI, conjugate of Z1 will be what? A minus what? BI. Therefore, Z1 times its conjugates will be A squared plus what? B squared. This is one of the properties of what? Conjugates. That when you multiply two conjugates together, their result will always give you what? A real number. I want to prove this. So let's see it together. If these two are conjugate of each other, let's take Z1 times what? Z1 conjugate. What will it be? What's our Z1 here? Is A plus BI, right? Times, what's our Z1 conjugate? Is A minus BI. Let's multiply this out. A times A will give us what here? A squared. A times minus BI will give us minus ABI. Is that not? Then BI times A will give us plus ABI. Then here we have BI times minus BI will give us minus B squared I squared, right? Of course. A times A is A squared. A times minus BI is what? Minus ABI. Then BI times A is what? ABI. Then BI times minus BI is what? Minus B squared I squared. Because B times minus B is minus B squared. Then I times I is what? I squared. Okay. Minus ABI plus ABI is 0. So these two will literally cancel themselves, right? Remaining what here? A squared. Is that not? Okay. Here we have A squared. The minus B squared times I squared in complex number, we have defined it as what? Minus 1. So here will be what? Minus 1. So this will give us A squared minus plus rather, because minus 1 times minus B squared is what? Is B squared. Are you there? So that means that if we have this expression, Z1 times Z1 conjugate, the result must always be what? A squared plus what? B squared. So the conjugate, when you multiply two conjugates together, the result must always give us a real number, right? This is the first property of conjugates I want us to take note of. Then the second property of conjugates, although I won't be proving this, just take note that whenever we have Z1 plus Z2 odd conjugates, meaning after adding Z1 and Z2, then get their conjugate is equals to Z1 conjugate plus what? Z2 what? Conjugate. Please take note of this. This is another property of conjugate. Then also, number 3, if we have Z1 times Z2 odd conjugate, the result is also Z1 conjugate times Z2 conjugate. Please take note of this as well. Okay. All right. So, sorry, let me put on my lights. Are we there? Now let's proceed further. The next question or the next principle, let's look at. Okay, let me ask this question. Let's look at some other conjugate question. Find the conjugate of the following. Find the conjugate of the following. Find the conjugate of the following. The first one is Z1 equals to 2 plus 3i. Number 2, Z1, or let's say Z2, equals to 3 minus 4i. The third, Z3 equals to minus 6i z4 equals to 10i z5, this is number 4, number 5, z5 equals to minus 20. Okay, let's say here we have z6 equals minus 15i. Okay, so if we are to find the conjugate of this, what do? Conjugate simply means the reverse sign of the imaginary part of a complex number. So the conjugate of z1 equals 2 plus 3i will give us z1 conjugate, right? Which is equals to 2 minus 3i, meaning the reverse sign of the imaginary part will be what? 2 minus 3i. So for this, number 2, number 1, number 2, if we have z2 to be equals to 3 minus 4i, what will be the conjugate of this? The result will be 3 plus 4i. So z2 conjugate is what? 3 plus what? 4i, right? So number 3, what is z3 conjugate? z3 is equals to minus 6i. So its conjugate will be what? Will be 6i, right? Will be 6i. Number 4, z4 conjugate. What will it be? Here we have 10i. The answer will be what? Minus what? 10i. Number 5, if we have z5, what is z5 conjugate? z5 is minus 20. Don't forget that conjugate only affects the imaginary part of a complex number. So the conjugate of z5 will remain the same. So if I have z5 equals minus 20, it will remain at minus 20. Reason because minus 20 is a real number, not an imaginary number. Okay? Likewise, okay, here I'm supposed to say if z6 equals to 15, if z6 equals to 15, what will be the conjugate of z6? The result is still what? 15. Because why? 15, not 15i. Okay? If z6 equals to 15, that means the conjugate of z6 will be what? 15. Okay, that is just how it is. Conjugates only affects the imaginary part of a complex number. It only affects the imaginary part of a complex number, right? Okay, please, if you are following up the class, indicate in the comment section. If you are following, if you are active, please indicate. If you are active, please indicate. If you are active, indicate. Just mention that I'm active, so we can continue with our class. If you're active, please indicate in the comment section. Indicate in the comment section, all right? Are you there, somebody? If you're active, indicate in the comment section. Indicate this in the comment section. If you're active, please, I need more comments. If you're active, indicate. Only one person is active. Doesn't mean other people who are online are not active. Please indicate. And let's keep on sharing the group link to others. Okay? Keep on sharing the group link. If you have shared this, say I've shared. If you have shared, say I've shared. If you have shared, say I've shared. All right, so let's move on to the next part, which is division of complex number. Division of two or more complex number. Now we have seen how to find the conjugate. Find the conjugate of two or more complex number, right? We have seen how to find the conjugate of two or more complex number. I want us to look at the division of two or more complex number. Division of two or more complex number. Two or more complex what? complex number of two or more complex number. All right. Okay. All right. I hope the video is clear. Hope it's clear, right? Like I promised, tomorrow's class will be awesome. I'll work on this camera and all that. Okay, division. Listen, before you know how to you go into division, you must have fully understand what conjugate is all about, right? Because without knowing how to find conjugates of a complex number, you cannot know how to divide. All right? Please take note that, right? In dividing two or more complex number, we have to rationalize the denominator. Let's say, for instance, now, if we are given that Z1 is equals to what? A plus what? BI. And Z2 is equals to C plus DI. And we're asked to find Z1 over what? Z2. Z1 represents the numerator in mathematics, right? While Z2 represents what? The denominator. So what we do is that we have to rationalize. We have to rationalize. Rationalize simply means I will multiply. I multiply the conjugate of the denominator with the numerator and what? The denominator itself. The conjugate of Z2 is what? C minus DI. Is that not? So to divide this, I'll bring out my Z1, which is what? A plus BI. Divided by what? What's my Z2? C plus what? DI. Then multiply this with the conjugate of C plus DI, which is C minus DI over what? C minus what? DI. Are you following? Then from here, I can proceed. I'll multiply A with C. What is A times C? That will give us what here? AC, right? What is A times minus DI? That will give us minus ADI, right? Minus ADI. Don't forget, A times C is AC. Then A times minus DI is what? Minus ADI. Then let's look at BI times C will give us what here? BCI, right? Then BI times minus DI will give us plus BDI squared. All divided by C times C will give us. Don't forget that this denominator, they are conjugates. Don't forget I say that if I'm multiplying conjugates together, for example, if I have A plus BI times A minus what? BI. What will be the result here? Is A squared plus what? B squared, right? A squared plus B squared. So since these two are conjugates, the result will be what here? C squared plus what? D squared. Even if we expand this, at the end of the day, the value of some values will cancel out. Then we'll be left with what? C squared plus what? D squared. Now let's evaluate the numerator. Okay, yeah, I'm not using actual value, right? But after this, I'm going to use an actual value to simplify this. So let's go. We're going to find out that we can evaluate further, right? Here will give us what here? Our Z1 over what? Z2 will give us, we have AC. AC. Between these two, what is common is I, right? So I can bring out my I here. I can say plus I is common. If I is common, what's the many years? What is AD? AD plus what? Plus BC, right? Plus BC, then plus BD times minus 1. Let me repeat again. Here we have AC, right? Between these two factors, we have I, so I is common. Then what's remaining here is what? Is minus AD. Minus AD is remaining here, minus AD, right? Okay. Then plus BC, plus what again? BD. I squared represents what? Minus 1. All divided by C squared plus what? Plus D squared, right? So Z1 over Z2 then becomes what? Here will give us AC plus I in brackets minus AD plus what? Plus BC minus BD, all divided by C squared plus what? D squared. I'm just showing you how to divide. The most important thing is that before you divide this with this, look for the conjugate of what? Of C plus DI, which is what? C minus DI. Multiply the conjugate by any value you have here, also by what? Any value you have here. Do you get the concept? Let's work with actual value and see. If we have a value, let's say if I have my Z1 to be equals to 2 plus 3i, okay? Then my Z2 to be equals to 3 plus 2i. And we have to find number 1. Z1 divided by what? Z2. Okay, now to solve for this, it's very simple. Like I told you, I'll bring up my Z1, which is 2 plus 3i, divided by what? My Z2? 3 plus 2i. I'll multiply this with the conjugate of what? Of my Z2. Conjugate of 3 plus 2i will be 3 minus 2i. Divided by what? 3 minus what? 2i, right? Okay, now let's move on. So Z1 over Z2 will be 2 times 3 is 6. 2 times 2i is what? Sorry, 2 times minus 2i is minus 4i. I repeat again, 2 times 3 is 6. 2 times minus 2i is what? Minus 4i. 3i times 3 will give us plus 9i, right? Then 3i times minus 2i give us minus 6i squared. All divided by 3 times 3 is 9. 3 times minus 2i is minus 6i. 2i times 3i, 2i times 3 will give us what again? Plus 6i, right? Okay, then plus, or rather, minus 2i, right? Times minus 2i will give us minus 4i squared. Is that not? Or I can just say, don't forget I say that if I'm to find the conjugate of the numerator, of the denominator rather, this will be 3 squared, right? Plus 2 squared. 3 squared plus 2 squared. But let's see if this will give us the same thing as 3 squared plus 2 squared on the denominator part, right? Let's see. Okay, so what we do here is to further evaluate, right? So let's go. Let's move on. So here we have here. Sorry, I'm coming. All right, so I have to just fix one or two things. Now let's finish up this. So here we have 6, right? Z1 over what? Z2 equals, here we have 6 minus 4i plus 9i. That should give us 5i, right? Plus 5i, then minus 6 times minus 1. Don't forget that I squared represents what? Minus 1. All divided by minus 6 plus 6 we cancel out. Then we are left with what? 9 minus 4 times minus 1, right? So Z1 over Z2 then becomes what? 6 minus 5i plus what? 6, right? All divided by 9 plus minus 4 times minus 1 will give us what? Plus 4. Okay, are you seeing that? Truly, if I'm to find the conjugate of this, it's simply square of 3 plus what? Square of 2. Square of 3 is what? Is 9. Square of 2 is what? Is 4. Are you seeing it from here? Okay, so let's move on. So my Z1 over Z2 becomes what? 6 plus 6 will give us what here? 12. Minus what? 5i. All divided by 13. I can decide to split this into 2. Then my Z1 over Z2 becomes what? 12 over 13 minus 5i over 13. So that the real part of this, the real part of Z1 over Z2 becomes what? 12 over 13, while the imaginary part becomes minus 5 over 13. Don't forget, imaginary part here is what? Minus 5 over what? 13. Okay, let's finish up this. Or let's repeat. Let me show you. Let me repeat again for those of you who just entered, who just came in. We have 2 times 3, we have 6. 2 times minus 2i, we have what? Minus 4i. 3i times 3 is what? Plus 9i. Then 3i times minus 2i is minus 6i squared, right? Okay. So here we have 3 times 3 is 9. 3 times minus 2i is minus 6i. 2i times 3 is plus 6i. Then 2i times minus 2i is what? Minus 4i squared. These two, they will cancel out because minus 6i plus 6i is 0. So here we have 6. Minus 4i plus 9i is plus 5i. Minus 6 times I squared represents what? Minus 1, right? Okay, so here give us, we have 9 minus 4 times minus 1. So minus 4 times minus 1 will give us plus 4. On this side here, minus 6 times minus 1 is what? Will give us plus 6. So this and this are like terms. 6 plus 6 will give us what? 12 minus 5i, all divided by what? 13. So the real part, I can split this into 2, which is 12 over 13 minus 5i over 13. So the real part of this value is 12 over 13. Imaginary part is minus 5 over what? 13. Okay, let's finish up. Okay, so we'll be rounding up with this first set. Then by tomorrow we'll continue from where we stopped. All right. By then, I must have been able to fix the camera. All right. So sorry for those who were unable to view proper. Then our next class, I'll be talking about what we call the polar form of a complex number. The polar form of a complex number. We have some forms we'll be looking at. The first form we'll look at tomorrow is called the polar form. The polar form of a complex number. And the general expression is z equals to, okay, r cos theta plus I sine theta, right? Number 2 form we'll look at is called the Euler's form. The Euler's form. That form says that z equals to r exponential I theta. Some person call it exponential form. Then the third form we'll look at will be the sixth form. The sixth form, which is also z equals to r6 theta. R6 theta. Then the other form will be what we call the power form. The power form, and also called the De Moivre's theorem, De Moivre's theorem, De Moivre's theorem. That form says z raised power n equals to r raised power n. In bracket, we have cos theta times n plus I sine theta times n. Okay, this is called the De Moivre's theorem. All right. Okay. Then the other form we also look at tomorrow is going to be what we call the n-tooth form. The n-tooth form. The n-tooth form. That form is given as z equals to r raised power 1 over n theta over n plus 2 pi k over n plus I sine theta over n plus 2 pi k over n. Okay, then after all of this form, we also look at how to divide polar form and how to multiply polar form of a complex number. Okay, I'm going to stop here for now so that we can digest on what we have learned so far in today's class. So tomorrow, or finally by 3 p.m., we continue with all of this form. Don't miss tomorrow's class by 3 p.m. online. Tomorrow by 3 p.m. Why we have to choose 3 p.m. is because some of you will be in church, right? So by 3 p.m., every one of you is expected to be around by 3 p.m. All right. We look at the polar form, the Euler's forms. We look at the cis form, the power form, the n-tooth, then how to divide and multiply in polar form. Then we look at a diagram called the Argand diagram. How to find your argument, how to find your amplitude, your modulus, and so many other questions. Then I'll be solving every question in Imo State University past question and also Uniben and UNN past question regarding complex number. All right. So don't miss the class. Ensure you are active tomorrow. Thank you so much, guys, for being online. I really appreciate you guys. Thank you. All right. So we are done. We are done for today. We are done for today. All right. We are done for today. If you have any question, you can ask your question. I'm open for question now. I'm open. Please, if you have any question, you can ask your question. All right. If you have any question, you can ask. Any question you can ask. Any question you can ask. I'm open for question. I'm open for question. If you have any question, you can ask. So tomorrow's class, we are starting by 3 p.m. tomorrow. Don't forget that we are starting tomorrow by 3 p.m. The class will be so intensive. It will be so intensive. Please don't forget. If you have any question, you can quickly ask this question. This class will be online for those of you who just joined us, who came in very late. So you're going to be having the video. I will download it and make it available for other people to access. All right. Thank you, guys.